Hello and welcome to my channel. In this video we will solve problem 7 and 8 of exercise 13.1 in 12th class math. So the 7th problem is two coins are tossed once where first E tail appears on one coin, F one coin shows head, and second E no tail appears, F no head appears. So here we have to find the probability of E such that F has occurred. Okay, so two coins are tossed. This is the random experiment, and in the first sub problem E and F are given. In the second sub problem also E and F are given. We have to find probability E such that F has occurred. So let us start solving the problem here. So first of all, it is given that two coins are tossed, right? So that means sample space you have to consider. So it is H, that means head in the first toss, head in the second toss, or head in the first toss, tail in the second toss, tail in the first toss, head in the second toss, and tail in the first toss, tail in the second toss, right? So this is the sample space. Now first sub problem, so E is given as tail appears on one coin, right? And F is one coin shows heads. So let us write the event in terms of set. So E is equal to tail appears on one coin, so that means head and head tail, this sample point will be there, then tail head, right? So this is the set E, and set F will be what? Set F is one coin shows head, so that means HT. Here two coin shows head, so we want that exactly one coin shows head, so head tail we got, then tail head, right? Then we have to look at E intersection F. So E intersection F is equal to, so you can see both the elements are common to both of them, so that means HT TH, right? Now we can find probability E such that F has occurred, so that is equal to probability E intersection F divided by probability of F. This formula we know, right? So this is equal to, now probability of E intersection F is what? So there are two elements in E intersection F, so that is 2 divided by the total elements, that is elements in the sample space, number of elements in the sample space, that is 4, divided by PF contains F contains 2 elements, so again 2 divided by total elements, that is elements in the sample space, so 4. So this will give us 1, right? So now let us find out the second answer. So first we have solved, second is what? Here it is. So second, so E is given as no tail appears, and F is given as no head appears, right? So that means E is what? No tail should appear, so that means H, right? And F is no head should appear, so that means F will be nothing but singleton set tail, right? Now if you look at the intersection of E and F, it is empty set. Okay, so now if we find PE such that F has occurred, that is equal to probability of E intersection F divided by P of F, so that is equal to, now since E intersection F is empty, so the number of elements in E intersection F is 0. So 0 divided by total number of elements in the sample space. So 4. PF contains one element, so 1 by 4. So this will give us 0, right? So this is the answer of the problem. Let us go to the next one. So here 8th one, a die is thrown 3 times. E4 appears on the third toss. F 6 and 5 appears respectively on first 2 tosses. Okay. So a die is thrown 3 times is given to us, and E and F events are given. We have to find what? We have to find probability. Okay, I'll write here. Find probability E such that F has occurred. So let us solve this problem. What is given that we will write first? A die is thrown 3 times. Okay. Now we don't need to write the sample space because sample space contains 216 elements. Okay, that we cannot list here. So you have to understand that you have to only understand how many number of sample points are there in the sample space. Okay, so here number of elements in S will be what? So you know, when the die is thrown 2 times, what is the sample space? So we get 6 into 6, because when die is thrown 1 time there are 6 outcomes, when another time it is thrown again 6 outcomes. Now when die is thrown 2 times, we will get 6 multiplied by 6, that is nothing but 36. So similarly here we will get 6 into 6, right? So that is nothing but 216. So this many elements are there in the sample space. Now let us write what is given again here. E is appears on 4 appears on 4 appears on the third toss, right? So let us write this set first. E is nothing but, now 4 appears on the third toss means you can get you will get elements like 1, 1, 4, right? And then 1, 2, 4, like this. Now if you see this, what happens is the number on the third die remains constant, you can see, right? Because you have to take 4 appears on the third toss. So this the number on the third dice, or the third throw, number on the third throw remains same. So that means you will get 1, 1, 4 and 1, 2, 4. So it is as good as throwing dice 2 times only, because the third number remains constant. So like this you can get up to 1, 6, 4, right? Then you can get like this 2, 1, 4, 2, 4, right? Then 2, 6, 4, okay, like this. So up to here you can get up to 6, 1, 4, then 6, 2, 4, okay, and 6, 4. So as I said earlier, the third number remains constant, so it is as good as throwing dice only 2 times. So how many elements are there when you throw dice 2 times? So number of elements in E are 36, right? 6 into 6. Okay, now let us go to the event F. So event F is what? Event F is 6 and 5 appears respectively on first 2 tosses. 6 and 5 appears on first 2 tosses. So F will contain this respectively, also it is important, appear respectively. So that means in the first toss 6 will get, in the second toss 5, and then this number, the third number will change, right? So you can get 1 6 5 2, then you can get 6 5 3, and 6 5 4, right? 6 5 5 and 6 5 6. This is the event F. Now if you look at the intersection E intersection F, so you can see that the common element is only this here, 6 5 4, and here it is, right, 6 5 4. Okay, so this 6 5 4 only the element is common. Okay, now if you want to find the probability E such that F has occurred, the formula is probability E intersection F divided by probability of F. So this will be equal to what? How many elements are there in E intersection F? 1. So 1 divided by the total elements in the sample space, that is 216, divided by PF contains 1 2 3 4 5 6 elements, and divided by total number of elements in the sample space, 216. So 216 will get cancelled, will get 1 by 6. Okay, so this is the answer. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.